Do you think the biggest cost in AI is the hardware? Think again. That $250,000 server you just bought is only the down payment of the machine that is not going to stop charging you money across your entire lifespan. Because once it's powered on, your cost is not going to stop. In fact, it's going to multiply. A single high-end server, let's say one with NVIDIA H100 GPUs, could easily run you to $250,000 to $400,000 depending on the setup. And some enterprise systems even cost about $500,000. But the first check you write, that's just a price admission to the college. The real cost is the one that keeps draining your budget, is hiding in the fine print. In fact, a study done by Epoch AI found that the frontier model training hardware accounted for 40 to 60% of the cost in their sample. Today, I'm going to pull back the curtain on the hidden economics of AI hardware and how it quietly turns your investment into a perpetual money pit. Let's first talk about the power and the cooling nightmare. Okay, now picture this. You have the new server, you're excited, you unbox it, you plug them into your data center, you flip the switch. Then the first electricity bill lands on the table and your jaw drops on the floor. Your financial team is worried. Welcome to the first lesson in AI economics. It's insatiable appetite for power. Each NVIDIA H100 GPU can draw around 700 watt under full load. If you multiply that by 8 GPUs at 5.6 kilowatt per system. The typical US consumption power rate that is more than $7,000 a year in electricity just for one server. And that's just half of the story. Every watt you feed into those GPUs, they're going to get heated. So you have to fight the heat, and that's very expensive. Modern data centers rely on liquid cooling systems, which can add another $15,000 to $100,000 depending on your setup. So you need more power for your cooling system. Cooling alone can account for 30 to 40% of the total data center energy consumption. In fact, the International Energy Agency even projected by 2030, the data centers could consume about 4% of world's electricity, with AI being the primary driver. So yes, you're paying it twice. Once you run the chips and again, stop them from melting. Let's also look at the maintenance. Now you have handled the power bill, you're cooling down the servers. Now you just need to run and keep printing money, right? Not really, not even close. Welcome to the maintenance money pit. For AI system, maintenance is not just about swapping a fan like you used to do in your old computer. It is constant and a costly process that can consume about 15 to 25% of your initial investment every single year. First, you're dealing with the model drift. AI models age, we all know that. We have seen with ChatGPT. As the world changes, data shifts, performance drop. Retaining to stay accurate can cost anywhere from $10,000 to $110,000 a year. Then you need the team. You need the machine learning operations engineers, data scientists who earn between $120,000 to $250,000 a year. Because for many businesses, every minute of downtime it's costly. Now, Gartner estimate unplanned outages can cost hundreds of thousands of dollars per hour. Then you add in the firmware update, the cluster management, patching, and your operating costs can easily top $100,000 to $150,000 per system. Now, this is not just a one-time purchase. It is a subscription for life. Then let's talk about data. Your servers are running. You're cooling them really well. You have a maintenance team and staff. Everything is done. But what are they actually doing? They're feeding data, which is the future of AI. And managing the data, that is the most underestimated cost of all. I have been in data space for 20 years, and I can tell you, acquiring these data sets can cost from a few $1,000s to well over $100,000 depending on the source. The real expense, in fact, on the data is the preparation, which is cleaning, labeling, organizing, normalizing. Studies from McKinsey has shows that this step alone can cost anywhere from 25 to 40% of your total AI project. Then it's not over yet. You have the storage. AI needs high bandwidth NVMEs or SSD storage. They're costing like 100 to 200 per terabyte per month, plus backups and redundancy. And don't forget the data governance with GDPR, CCPA, privacy compliance is an obligation, and we have new European AI law. To make things worse, the memory bandwidth has become a bottleneck. Companies often buy more expensive GPUs than they really need to get that extra memory. Because of that, you're not just building a model, you're building a perpetual data factory that is not going to stop costing money. Then we have the software and the licensing. You got the power, you got the cooling, you got the team and the data. But without the software, the server is just a $300,000 paperweight. And this is where the companies get trapped most of the time. AI runs on licenses, subscriptions, and variety of platform fees. Development environments like Databricks, Snowflake, or NVIDIA DGX Cloud can cost anywhere from a few thousand to over $100,000 per month. Then you have integration. You need to integrate all of this into your existing systems, getting your AI system to actually talk to your infrastructure. That usually means a custom connector, you have a middleware, you have APIs, which can add six-figure to your engineering cost. Now, even if you have your own hardware, many workloads are still going to be depending on cloud services for storage or inferences. Each one of these are adding another recurring bill to your bottom line. It's kind of dead by thousands of paper cuts, a hidden software tax that never stops charging you. So we talked about all these problems. So what is the solution? So how do you avoid this black hole? My recommendation is you build a total cost of ownership model before you do anything with AI. Don't guess it, calculate it to the T. Here's my 4-part blueprint. The first is energy and facilities budget. Take your server's peak draw, multiply that by the energy cost, and a PUE of 1.5. That is going to give you your energy bill annually. Second is operational and staffing budget. Set aside 15 to 25% of the hardware cost per year for engineers and retaining and support. Third is data lifecycle budget. Reserve 30% of your total project costs for data acquisition, cleaning, labeling, storage, the whole enchilada. 4, software bills of materials. List every license, platform, and cloud fees. This makes your hidden software tax visible to you and your financial organization. The companies winning with AI are not just the ones that are buying the biggest and the most expensive servers. They're the ones who are understanding the full financial picture and planning for it. Most AI pilots are not failing because the technology is bad. They're just failing because the economics don't work. And you see this on the news all the time, why the return on investment is not great. If this breakdown gives you a new perspective on AI investment, hit the button and subscribe. I do these types of deep dives every week to help you cut through the hype that's around AI and make smarter and data-driven decisions. And now, if you're seeing on the screen the video, which is going to help you guide through how companies like yours is making these powerful agentic decisions in this AI economy.